2.6, an introduction to sine, cosine, and composite functions. Composite functions are where you put one function into another function. Your essential question, what are the derivatives of the sine and cosine functions? And in order to help us explore that, I'm actually going to go back to section 3.5, which on page 100, there were two problems that we didn't do, 21 and 22. And I've given you a handout with copies of those graphs here. So we are going to look at page 100, 21 and 22. And the directions say, sketch the graph of the derivative function on a copy of the figure. Make a conjecture about an equation for the derivative function. Okay, so on our copy, we need to sketch the graph of the derivative function. All right, so starting with the sine function. So to find the derivative function of the sine function, or any function, the first thing I like to do is I like to find my critical points. So I can see that I've got a max here. And so the slope of the tangent line there is going to be 0 because that's a horizontal line. So I'll give myself a root on my derivative graph. Okay, same thing at this minimum, right? Horizontal tangent line means derivative of 0, approximately there. Okay, and then same thing over here at this maximum, horizontal line, so derivative of the tangent, or the slope of the tangent line would be 0, so that's about a root there. Okay, now in between these roots, I'm going to try and find some slopes to kind of help me out. So if I looked at maybe x equals, what is this, 1, 2, 3. If I look at x equals 3, okay, the slope around x equals 3, well, it appears to go down about 2 and over 2, so that would be about -1. So I'll have a point there about -1. Maybe somewhere between these two roots, right, about this point, okay, this x value, if I think about the slope around that area, kind of the same things happening. We're going about up 2 and almost over 2. So that's like a +1, so put that about there. If I do the same thing like at x equals 0, it's about the same type of slope, about a +1. Okay, and if you think about, the slopes kind of between there, like for example over here on this extreme end, well, that's a negative slope, right? So I'm going to have some negative values coming down. And I'm not sure exactly what, but what I do know is that if I connect these, I'm getting another periodic function. Look. Well, it wasn't perfect, but it was darn close. Okay, so I'm going to highlight my derivative function. And I'm hoping that this function looks familiar to you. So this yellow is the derivative with respect to x of sine of x. And this should look very familiar to you. So your y-intercept starts at 0, 1. And then you head through the x-axis down to -1, up through the x-axis, back up to +1. So this happens to be the cosine function. So when you take the derivative of sine of x with respect to x, you get cosine of x. You can derive this each time, or you can memorize this, and I would highly recommend memorizing this. All right, so let's try this again with cosine now. So same type of thing, everywhere where I have a critical point, like here, I'm going to have a horizontal tangent line, which means that the slope of that is 0, so the derivative will be 0 at those critical points. So I always like to start with those. And then looking in between there, right, if I look at this x value here of the original, or the x-intercept of the original function, y equals cosine of x, the slope appears to be, about down 2 and over 2, so about -1. Okay, same thing here. Let's look at the slope around here. So that's going to be positive, and it's about +1. And same thing around this one. Basically, it's going to be around -1, right, at that x-intercept. Okay, so let's see what this looks like. Oops, what did I do? I put a dot there when it should have been my root. So that critical point there, hopefully you caught that. That critical point should be a 0 on the derivative graph. Okay, so that's a -1, and then it starts increasing again, so it looks something like this. So if we were pretty good at this, we'd say to ourselves, oh, well, let's see. If the derivative of sine of x is cosine of x, then the derivative of cosine of x should be sine of x. And it kind of looks like the sine function, right? It starts at 0, 0, but it doesn't go up initially. It goes down, right? So this is the sine function that has been reflected in the x-axis. So what does that mean? Think about it for a minute while I highlight my... So basically, this right here is the derivative with respect to x of cosine x. It doesn't necessarily give you the sine function. It gives you the sine function reflected in the x-axis, which is the negative sine function. Okay, so that's another one that you're going to want to memorize. So, to start our notes out, we know that the derivative with respect to x of sine of x is equal to cosine of x, and the derivative with respect to x of cosine of x is equal to negative sine of x. Those are super important. You're going to want to memorize them. We're going to give you a whole bunch more to memorize, but these are pretty darn important.